Okay, ladies and gentlemen of geometry, this is the last section in Unit 6. We're talking about angle of elevation, angle of depression. Now, those things have pretty real meanings in the real world. Angle of elevation, pretty much the angle you take. Think about like an airplane taking off. The angle of elevation would be the angle between the plane and the ground. Angle of depression would be kind of the angle between flying straight ahead and flying towards the ground. So, the angle of an elevation is of an object is seen by an observer is the angle between the horizontal and the line from the object to the observer's line of sight. So think about this in a real simple context, okay? You've got a person, all right? They're looking straight ahead. All right, up in the air you've got a balloon. Okay? From the line of sight up to the balloon, this is your angle of elevation. All right, so that is your angle of elevation. From looking straight ahead to looking up to an object, that angle itself is going to be your angle of elevation. Angle of depression is kind of the same, except you're looking from up top and you're looking down. So I like to think about it this way. Think about if you're standing on the edge of a cliff, you're looking straight out, but then down here in water, because this is the international symbol for water, you see a boat. So you looking down at the boat, this becomes your angle of depression. Now, what a lot of kids like to screw up is that they somehow think that if I drew a line straight down, a lot of kids like to think this is your angle of depression. I don't know why, but this is absolutely not the angle of depression. So you've got to be careful about that. The angle of depression is from looking straight ahead to looking down. All right, so draw a sketch to represent the problem, include the given numbers and a variable to represent the unknown, show the trig equation needed to solve, and then give the solution. So a tree casts a shadow 25 feet long. The angle of elevation, ding, 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 there's keywords right there. From the tip of the shadow to the top of the tree is 64 degrees. Find the height of the tree. All right, so you got a little picture here, but we'll draw. Here's the tree. I know, I realize I have the drawing skills of a second grader, but I don't care. So the shadow reaches here, and that's 25 feet long. And the shadow to the top of the tree is 64 degrees. And what they're trying to figure out is, what is the height? Well, what you got to realize is that this is a right triangle. All right, so you got a right triangle. You're looking for the height. You've got the length from the tree, and you've got an angle. So what you've got is a trig function, except this is your opposite, this is your hypotenuse, and this is your angle. So opposite hypotenuse, don't forget, is tangent. So I'm going to take the tangent of 64, and that's going to be equal to the height I'm looking for over 25. So once again, tangent 64, I can put that into my calculator, make sure I'm in the right mode. Go into degree mode because I'm not there yet. So tangent of 64, in this case I'm going to multiply by 25. I get that height to be 51.26. This will be feet. So that's my answer. All right, 51.26 feet. All right, so a jet takes off and rises at an angle of 19 degrees with the ground until it hits an elevation of 28,000 feet. How much ground distance is covered in miles? All right, so taking a look, this takes up a lot of space, so we're going to have to kind of draw it underneath. So jet takes off at an angle of 19 degrees, and the elevation, the height here is 28,000 feet. What they want to know is, how much ground distance. So what is this distance going to be? All right, so 28,000 is this height. They want to know how much distance did I cover. Well, again, tangent's begging to be used, okay? Because here's my angle. This is my height, or this is my opposite, and this is my adjacent. All right, so what it's going to look like is this. The tangent of 19 is going to be equal to 28,000 over the distance. So if you remember what happens, these two switch places. So my distance becomes 28,000 over the tangent of 19, whatever that is. Put that into your calculator. Tangent of 19 degrees is going to be 0.3443. So take 28,000 divided by that answer, and you get 81,317.9 feet. But realize, this is in feet. So I've got to divide that by 5,280. So divide by 5,280, forgive me, so I get 15.4. That's going to be my answer. 15.4 miles. All right, so from the top of a vertical cliff 40 meters high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? So you're here at this cliff is 40 meters high. 40 meters high. The angle of depression of an object that is level with the base of the cliff is 34 degrees. So looking down here, this is 34 degrees. This is not 34 degrees. All right, this one is 34 degrees. That's your angle of depression. So how far is the object from the base of the cliff? So this is 34. You know what? This is still 40. So you're looking for this distance because that's going to mirror this distance. So again, tangent usually plays a big role in this one. So tangent of 34, and then be careful because a lot of kids will screw this up. Do you want 40 over D or do you want D over 40? Well, you want 40 over D. Opposite over adjacent. That's how you're going to solve this thing. So what I want to have happen is this. I want to swap these two. Of 40 divided by the tangent of 34, and that's going to be 59.30, so 59.3. So I'll say 59.3 meters away. So not quite 60 meters away from the base of the cliff. So the pilot sights the beginning of a runway, must approach it at a 5-degree angle of depression. The plane is 182 kilometers from the beginning of the runway. What is the plane's altitude, height in the air, round to the nearest kilometer? So airplane is here. The plane, the ground, is 182 kilometers away. The angle of depression down here is 5 degrees. That is your angle of depression. All right? Not this. Don't tell me that this is 5 degrees. That's not going to work. That is your angle of depression. What is the plane's altitude, which is this? But that's going to be the same as if I was over here. So this is 5 degrees. This is 182 kilometers. I want to know the height to the nearest kilometer. So again, tangent. Tangent plays a big role. But I want tangent of H over 182, okay? And for those of you guys that haven't noticed, this just makes a great big rectangle. But all I want is this triangle, the right triangle right here. That's the one I'm working with. All right, so the tangent of 5 degrees, tangent of 5 equals all that. So tangent of 5 times 182. So I get 16 kilometers. Rounded to the nearest one, 16 kilometers will be my answer. All right, we got to be getting towards the end here. Hang with me. All right, surveyor is 100 meters from a bridge. The angle of elevation from the to the top of the bridge is 35 degrees. The instrument is 1.45 meters above the ground. Find the height of the bridge to the nearest tenth. All right, so here's kind of the deal. All right, so they got the little tripod thing with the little camera thing. All right, and that is looking up at an angle. So if this was straight out, that's looking up at an angle of 35 degrees. All right, now this instrument is 1.45 meters above the ground. All right, and the bridge is 100 meters away. All right, so it's 100 meters away right here. They want to know how tall the bridge is. Okay, well, so that's fine. We can do that, but all we got to do is remember to add 1.45 at the end. So this becomes 100 meters. This is my height, but I've also got to add 1.45 here to get the true height of the bridge. So just kind of putting a little wrinkle in here. So 35 opposite, adjacent means tangent. So tangent of 35 is going to be equal to h over 100. So again, go to the calculator. Tangent of 35 times 100 is going to be 700.21 plus 1.45 is going to be 701.66 feet. That's going to be my answer. So remember, all I did was kind of do the same thing I've been doing, except I added that 1.45 for the height of the surveying thing. All right, search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression of this other person is 42 degrees and the helicopter is 18 feet in the air, what is the horizontal distance from the rescuers to this person the nearest foot? So this is 42 degrees. He's 18 feet in the air. What is this distance? So I'm hoping that tangent is starting to jump out at you. So that'll look like tangent of 42 degrees is going to be equal to 18 over that distance, that straight distance across. So remember, all that happens is these two switch places. If you start getting the habit of that, your life gets easier. So if I take 18 divided by the tangent of 42, I get approximately 20 feet. That's 19.99. Round to the nearest foot, 20 feet is going to be your answer. Okay, that's all I got. Look through these examples. Be very, very careful about where you're putting the different numbers. Make sure that they're going to match up. Make sure you got opposite and adjacent correct. And then come talk to me with questions. Double check your calculator. Make sure that it is in degree mode. Otherwise, you're just going to get wrong answers all over the place. All right, thank you for playing. We'll talk to you again soon.